Alright, hello everyone. So sorry about the cruel joke of the last video. That wasn't actually the last video of the semester. This one actually is. So I'm excited about that. We're just going to cover making a confidence interval for a slope coefficient in multiple regression. And this should be pretty quick because as we're going to see, this is super similar as most of the stuff in this section is to section 6 when we did this for simple linear regression. And so remember we were working with this example about looking at whether there was an association between math SAT score and first year GPA. We did the hypothesis test, found that there was, even after accounting for these other effects. And so we could also make a confidence interval for that coefficient just to get a better idea of what that relationship is. And so from that table of output, we've already kind of written that our estimated slope for math SAT score is that. Also in that same row, that standard error we already wrote down as 0.00273. And so the only other thing that we need for this confidence interval is our critical value to tell us how wide we want to make the interval. And so our degrees of freedom, we also already wrote down were 995. And so what we want to do for a 95% confidence interval is head on over to StatKey, plug in 995 degrees of freedom, and click on the two tail. By default, it should already have 95% of the area in the middle. And so that cutoff you should check should be 1.96235. Then our interval is just going to be our point estimate plus or minus that t star value times the standard error. This is the same format that all of the intervals we've done in this class have been throughout the whole semester. Some point estimate plus or minus either a t or z star times the standard error. And so now for kind of the easy part, just plugging in the numbers, you should wind up with an interval from 0.01015 to 0.0209. Okay, and so let's come down to this conclusion and actually interpret what this interval means. So this is usually kind of the harder part, is the interpretation. And so what we're saying is, like in math speak, I guess, we're saying that the slope between first year GPA and math SAT score is between these two numbers. And so how we interpreted the slope, I'm going to leave a little bit of space here because we're going to write something else. But we said for a 10-point increase in math SAT score, what do we think is going to happen to the average first year GPA? Well, we think average first year GPA increases, and then instead of just giving a number like we did when we interpreted the slope, we're giving this range. Increases between 0.01015 and 0.0209 points. All right, so a couple things we have to add. Since we have other predictors, we want to clarify that this is as long as a verbal SAT, high school GPA, and sex do not change. So again, we want to clarify that we're only increasing math SAT score and seeing what's going to happen to first year GPA on average. These other predictors aren't going to change. We also want to add, like we usually do, how confident we're going to be. So we're 95% confident that blah, 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 blah. Okay, And so that rounds out the content for the semester. So kind of big picture, this last section is really just meant to kind of just show how much we can expand what we did for simple linear regression when we only had one predictor. And pretty much that when, as we're adding more predictors, not that much is going to change. So a model with kind of 4 predictors instead of 1 could potentially be like a lot more useful in examining relationships as well as in making predictions, as we've kind of seen in this GPA example. Okay, phew. So as always, let me know if you have any questions. After watching this video, we should just have the final exam left. So nice work, and I hope you have a great morning or afternoon.